So this is a presentation I put together, a part of it reasonably quickly, and hopefully it addresses a few issues. I could give about 4 different talks on that project as just an interesting case study. The images shown on the left from obviously strip out to completion and so on. But today I'm going to be digging into the life cycle assessment side of things. Just to say that there was a lot of talk there. Sinead was really great earlier on talking about skills needed. I should say just a quick plug, the School of Architecture, Building and Environment in TU Dublin provides the leading or possibly the only professional postgraduate program delivering technical transformative technical upskilling to building designers. So where you're looking to learn the actual tools and then integrate and practice and get feedback on the tools for life cycle assessment, design for circularity, building environmental assessment methods, building energy modeling using DEEP, building energy modeling using PHPP, hydrothermal assessment, thermal bridge calculation, etc. So many of the areas that we are looking to gain skills on, we're doing that. And you can come and get a government subsidy and spend quite a bit of time upskilling, but very little money, and get the software free, get the standards free, and lots of expert tuition. So that's available to everyone in the room. I'm sure everyone in the room, because I'm guessing most of you are building design professionals of some kind or another. So I'm drawing in this talk on the work of some of my MSc students. So one of my colleagues, Alberta Conchiduti, an expert in life cycle assessment, and then 2 of my students who recently graduated with distinctions did some really fantastic work on life cycle assessment, and in fact, and where life cycle assessment needs to go. And they presented that yesterday to SEAI, because SEAI, I think with some support from IGBC, is generating a carbon calculator, which will become the tool for accounting for the embodied carbon in your building. Those students did both graduated with distinction. Both of them looked at temporal aspects of life cycle assessment. We're looking at multiple life cycles. So if we're retrofitting and we're using those materials well, and we're designing disassembly, we should be able to reuse those materials in the next building cycle, and therefore the material flow, the carbon intensity of building, of material flow from this project, from this lifespan to this lifespan, it reduces the, so that kind of engagement with design for disassembly, circularity, etc. That's not accounted for at the moment in life cycle assessment. It's all accounted for in the first life of that accounting. And secondly, the other man looked at the impact of decarbonising. So if we do have and we require a decarbonising grid, as we heard earlier on from Keith and Sinead and so on, we should be accounting for that in our life cycle assessment. And of course, the building materials that we use will also start decarbonising. One thing is the chemical processes that they might create and so on. But actually, if we increasingly use electricity instead of gas or oil or whatever to generate those materials, and then that energy supply is decarbonising, we will also get a more environmental or lower impact from those materials. So that's something that isn't yet being incorporated into proper life cycle assessment. So effectively, we have what you call static life cycle assessment. I'm going to show you a case study that uses static LCA to look at the impacts of a particular case study and what we can learn from that. But then I'm going to take that further and show you just a few slides from both of those students where they are showing possibly where we need to go well, in fact, in Europe, not just in Ireland. Okay. Thank you very much. Sorry. Well done. Fill the space. So I'm going to go through a few things. Some of this comes from my student who also helped me in this particular case study, Sarah Carrigan, and then Sarah and Paul Alley did a master's recently with the help from Alberta and myself. And I'm going to look at some of what they're showing us in terms of where we're going with life cycle assessment. This is a tiny little cottage. It's only 38 square meters. I'm going to show you relatively little about that. That's an entirely other presentation, but hopefully that hopefully that works. So great studies by Oliver Kinnan and Mr. O'Hegarty there in UCD, looking at where we are in terms of embodied carbon and operational carbon. So at the bottom of the page, we've got operational. So it's all those. It's the heating, it's the cooling, it's the powering, and so on. And then at the top, the impact of the materials and demolitions and etc. So you can see we are still very heavy on the operational side. But if you go back to 2005. Or further back again, you can see that we are generally reducing the operational embodied the impact of operational energy, but the carbon has every potential to increase. And it's a fantastic study if you haven't seen it, from Oliver Cannan and co in UCD. If you take that a little bit further, this is almost the same graph, and you take an approach where we address embodied carbon in the bottom, and we don't address embodied carbon adequately for the works we do from now on. At the top of the page, the little black circle or oval, you can see we're here, we're broadly around there, and it's looking at the difference between that top and bottom. You can see the number of houses that we're building is increasing. You can see that the carbon intensity of energy in green is reducing, but we have a chance to do something right or wrong in the process of also meeting things like the housing crisis and so on. What are the choices that we make? So the top scenario doesn't really address embodied carbon for the next body of works that we need to look at. Savings in carbon emissions by improving our buildings will be offset by the addition of emissions embodied in the materials used to build new buildings, but also to upgrade the current ones. So all the work we're doing in terms of energy efficiency, which comes from that, even the first Environmental Performance of Buildings Directive, the EPBD, since what was that 2002, the introduction of DEEP in 2005 or 6 or so, all those big changes that we made in terms of efficiency operationally will be wiped out if we do not get our act together in terms of embodied carbon. I think Keith talked really well. Sorry, it was Keith, really well earlier on about getting the big guys on board. And basically half of that graph we saw earlier from industrial production was concrete. So in fact, my little case study, albeit it's 38 square meters, we did some innovative things in terms of not using concrete and other materials. And then in the bottom scenario, where it's quite possible to reduce the carbon footprint by building and constructing, reducing that by 50%, and then actually looking to find new buildings. We don't have a new building housing crisis. We have a housing crisis. The solution to the housing crisis is not necessarily to build more, it's to find more, it's to occupy more buildings. There are vast amounts of buildings in this city, in every town in Ireland, that are unoccupied or underoccupied. It's quite common, the ground floor, we all know this, the ground floor is occupied, the first floor is used for storage and the occasional meeting, and the other floor above or 2 floors above are empty, and so on. And actually the Irish Green Building Council at the moment is actually looking at talking to the government to account for those upper floors. They're not actually counted as residential units. So when they are occupied or become occupied, they're not accounted for in the process of addressing a housing crisis. If the government is not counting, if anyone doesn't count for something, it doesn't exist. You have to name a thing, you have to count a thing, and then you can actually engage with that thing. If you don't actually count the damn thing in the first place, you can't see it's whether it's contributing or not. So actually, even simple measures like actually registering that above the shop is empty, and once above the shop is filled by a suitable residence, actually counts against the housing crisis, would be a very, very good start. Okay, so there are lots of different things that we need to do. And one of the things that emerges from this understanding, and it was a IGPC report that Oliver and co were the lead authors on, is realizing that we have a limited carbon budget. We only have so much carbon. And we have to move away from a building as usual perspective in order to spend that carbon in the very best way possible. So there's a good example. Do we reoccupy above the shop throughout Ireland, or do we build another housing estate? There's a carbon conversation. There's a policy conversation. Somebody benefits from that, but does Ireland benefit from that? And does it benefit sufficiently in the context that's limited that we're now in? So if we looked at things like life cycle assessment, it's a very good way it's obviously the key way of accounting for that. It does miss some things, but it's a very fast emerging area. I don't know how much you all know about this, but I'm just going to go through it as if you don't. A methodology used to evaluate the environmental impact of a product or a product system. A full life cycle assessment in construction will evaluate the construction methods, the materials used, the weights and pollutants produced, and energy use across its whole life cycle. So the scenarios can be based on assumptions when the data is not known, but the more data we have and the more robust that data is, the better, obviously. And obviously a key standard in relation to this is 15978, might do that occasionally, to assess this in an orthodox manner. There's no point in lots of organizations having lots of different wonderful life cycle assessment methods, and we can't compare them. And not surprisingly, across Europe, we're already doing that. In the same way with BERs or EPCs, we've got each nation has its own approach, which makes comparison very awkward. which we're trying to resolve now with the new recast EPBD. We also need to do the same with life cycle assessment. So if you look at the kind of the process flow that results in materials being mined or extracted or cut down or whatever to products and so on, you can see kind of a pleasing little graph over there. And if you were looking at life cycle assessment and taking a modular approach, you can see the little rectangles at the top: product, construction, use, end use, and then below that is operational, energy, and water, that little tiny graphic. You can see that we're looking at various stages. Stages A1 to A3, for instance, is to do with product-associated emissions and so on. And then, like I said, the operational bit is really B1, sorry, is down here. B6 to B7, energy consumption and water use. So you can actually see it straight away. That little bit there is the bit we've been focusing on for the last 20 years to a really high degree, but actually we've been kind of ignoring the rest. So in the study I'm going to show you now, we looked at the global, there's a range of different environmental, oh no, my God, really? Yeah. Oh, that's shocking. Okay, so we looked at global warming potential and we looked at biogenic carbon storage. And we haven't paid as much attention to the others, but actually if you pay attention to those, particularly to the first one, the rest often follow. This is the cottage. I should say that it secured no grant aid from the government whatsoever because we were using low carbon materials, because we were using wood fibers, cellulose, post-consumer waste materials, limecretes, leca expanded aggregate in the floor, all of the materials that were actually appropriate and breathable for that building. We couldn't get grant aid. If we had used expanded polystyrene, if we'd used polyisocyanates, if we'd used phenolic, etc., we would have been able to secure some amount of government grant aid. And that's an uncomfortable thing to say, but it's true. We couldn't use a heat pump because it's 38 square meters, and it was literally too small to take up a square meter of the floor area. We have allowed for phasing, we have allowed for a solar panel in the future, and so on. And I could say lots more about that. These are the various things that we did to measure. One-click LCA was the tool that we used for the life cycle assessment. We came in when we did this assessment at, what does that say, 322 kilograms per meter, kilograms of CO2 equivalent per meter squared, which comes in at kind of B grade across Europe of carbon efficiency. And if you can see down below there, it's well below a pathway that's taking us to net zero, according to the carbon, what's called the carbon law, which I won't talk about now. You can see a lot of the materials, the blue area there, accounted for where the carbon was. And because the floor and the roof were such a large portion of the overall heat loss areas, heat losing areas, if you looked at the heat loss form factor, it was about 62% of the whole building. Not surprisingly, those elements have the biggest carbon. But what's really interesting here, we used a limecrete slab. We didn't use a concrete slab. 100 millimeters of NHL5 limecrete with polymer fibers to increase the tensile characteristic of that slab, on top of expanded glass aggregate, foamed glass aggregate. So 300 mil compacted to 250 and another 300 mil compacted to 250, because the void was there. The floor void was actually, including the slab, or what was from the floor finish to the original underfloor, was 600 mil. So with a 100 mil slab, 500 mil of insulation, which was also the aggregate, which was also the capillary break, we had a wonderful, breathable, insulating material with low embodied carbon for the slab, and the other 500 mil was 100% recycled material, post-consumer waste. So when you start looking at those kind of things, we also had a lot of wood fibers. We had 10 different types of biomaterials, and we had 4 types of post-consumer waste materials. So when you look at the green bar at the far right, 80% of the, there was an 80% negative. We were offsetting the impact of the positive carbon, the carbon emissions that we caused, by the specification of biogenic and post-consumer materials. So that kind of thing, all of those products are available in Ireland. All of those are commercial products that are fully tested, and you could use all of them yourselves. So that's quite significant. Now, when we reduce the embodied carbon by quite a lot, it does mean that the operational carbon, the yellow bar right at the top up here, this compared to that, when that was actually this, there is an issue there. Obviously, we efficiency building, but it's quite interesting how it distorts when you begin to use better and better, lower and lower carbon materials. It can distort the normal picture that you might see. What's really interesting is to look at where you're using a lot of materials and where you have the greatest ability to save So if you look at the external walls and facades, by mass, they make up a large amount of the building, but we saved the concrete, we saved the timber structure, so the embodied carbon impact of those was quite low, etc. One area there, a hotspot, the adhesive to hold down the timber floor, like the one we're standing on right now, actually turned out to be a kind of a carbon hotspot, which we didn't know, and we could have, we could do something about the next time, but it would also need manufacturers to help us with that. The carbon intensity of adhesive, that was a surprise. But then the cellular glass aggregate I mentioned a moment ago, 500 millimeters of it, there's a large mass, but it's very, very low in terms of carbon. So it's a really, really good place to make a good choice in terms of your specification. But that kind of thinking, when you bring life cycle assessment on at early stage. So we look briefly, this is an image from a range of materials we used. If you'd swapped out some of the materials we did use for materials that we did not use that are more conventional, they might include mineral wool instead of cellulose insulation, polyisis annular instead of a Pavadry wood fiber OSB composite board, Pavatextile, which is actually made from denims, recycled trousers or whatever, compared to mineral wool. And maybe if we'd rebuilt the walls, which were problematic, it was friable old concrete. But let's say if we rebuild them, what would the impact be there? And you can see from left, that's what we did do. But if we had made other poorer choices on the right, you can see the upswing in carbon that would have resulted from a poorer specification of that project. Not affected the operational energy, not affected the air tightness, not affected the comfort of the people, but would definitely, might have affected the moisture managing, but would definitely have in fact impacted on the lower line for carbon. Now, and then in terms of carbon storage, we would have reduced our amount of carbon storage. So we would have increased our embodied carbon and we would have reduced our carbon storage by a poorer specification. And by the way, when you do that, when you look at your global warming potential, the one on the left there, and how you can reduce that, you're generally naturally reducing all the other environmental impacts at the same time. I'm gone, am I? Okay, I'm gone. All right. So what I said at the beginning, when in fact there was a problem with the slideshow running, I talked about my two students. They will be publishing papers quite shortly, and they do look, like I said, at kind of multiple lifespans of carbon and how that can be impacted, how that needs to be looked at, and then also decarbonizing of the grid, and therefore decarbonizing of building materials and how that needs to be looked at. So this is very much an evolving space, and we need people on board. My last slide, so is this. As Sinead said earlier on, please get on board with Indicate. Like I said, we need to take account of these things. We have a limited carbon budget. We need to make better choices now. Thank you. Thanks, Donald.